Hello again. In this video, we're going to continue with section D.1, which is on page 56. We're going to start with an example on factoring. We've actually factored before. We factored in chapter 1. So let's review what we did. In chapter 1, what we did is we factor out the greatest common factor, if you remember. That's the type of factoring we did back then. So let's look at this little review. Let's factor the following. So 4x plus 8. The greatest common factor is 4. It's the factor that the number that is common in both. I see 2 is common in both, but we want the greatest common factor, and the greatest number that is common in both is 4. So what you do is you put a 4 on the outside and you divide a 4 into each. You get an x plus 2. If you notice, if you multiply that out, you do get back to the original. You can factor numbers or variables. So if we look at the part B here, y squared minus 5y, what is common there is a y. And we divide a y into y squared, you get a y, and then divide y into 5y, you just get a 5. And notice when you multiply it back, you get the original. So that is our little review. This section is a little different, because you notice there's nothing common in all three. Yes, in the first two there's a y, but with that 6 there, there's nothing common. So what happens here is if you have 3 terms that is quadratic, only when it's quadratic with 3 terms, they're called trinomials. It can factor into a backwards FOIL situation of what we did on the page before, into 2 terms. So with the first, outer, inner, last. This is going to be part of the first. This is going to be the outer and the inner, or the inner and the outer. This is going to be the last. So the first better be y squared. So this is going to be a y and a y. And then we have that 6 there. So you think of 2 factors of 6 that combine to the middle. So we want 2... I'm going to write it. 2 factors of negative 6 that add up to negative 5. That's how you get the outer and the inner with the last. So you would think to yourself, oh, I know it's going to be negative 2 and negative 3. Oh, that makes negative 5. But notice that does not work because this multiplies to 6. We need 2 factors of negative 6. And if we make one of those negative, well, let's just show that. If we make one of those negative, to make the negative 6, you don't get 5, you get negative 1. So you're really looking at 6 and 1. And we want the 6 negative because when you add, note if you multiply them together, you get negative 6. And if you add them, you get negative 5. So one is going to be a negative 6, and the other is going to be a plus 1. This does work. Look at the last, and then the outer and the inner. The outer is a 1, and the inner is a negative 6. It does work. So let's go ahead and do C first. I know I'm going to do it out of order. Just that same idea. So again, this is a trinomial. This is going to be the first. So this would be a b and a b. And then we're looking for all the factors of negative 24. So we're looking for 2 factors of the negative 24 that add to 2. So what are different factors of 24? Well, there's 1 and 24. Let me just write them all down. 2 and 12. 3 and 8. And 4 and 6. The only one that has a shot of working is the 4 and the 6. We want that, it multiplies, we want it to be negative 24, so we want one of those to be negative, and we want to be plus 2, so we want the 4 to be negative. So negative 4 and plus 6 should work. Or you could put plus 6 and negative 4. Again, let's just check it. We can do a check. The first works. This is the answer, by the way. We should put a circle on that so we don't get confused. Just checking it. The outer is a plus 6b. The inner is a minus 4b. And the last is a 24. And notice how this one is the first, right? These two are the last, and then the inner makes up the 2b. So that does work. This was the answer here. On this one, whenever you have a number here, it makes it a lot more difficult. And we have an x cubed. We don't have an x squared. But luckily for us, we're going to do it the chapter 1 way first. We're going to notice that 2 is common. Oh, and an x is common. So we're going to go ahead and do that first. And what we end up with is x squared. 2 goes into 32, I think 16 times. Is that right? With an x. And then 2 goes into 128. 64 times? Interesting. So then we're going to work, I'm going to keep that 2x there, and I'm going to work on this because I see it's a trinomial. It's 3 terms, and it's a squared. So I'm going to realize that the first is an x and an x. And then we're going to look for factors of 64. But notice how factors of 64, if I take 64 and square root it, it's 8 times 8. And if I double it, this is actually going to be the 16, isn't it? So I don't really have to go through all, if I can visualize it, I don't have to go through the whole list. But you can. This would be a 9 minus 8 and a minus 8. Sometimes if you don't feel like doing a long check, I just visualize the first. That works. The last, that's a plus 64. And then the inner and the outer, I make an upside down rainbow. I get a negative 8x and a negative 8x. That does add up to, I don't have enough room for that, I'll do it on the next one, but it adds up to negative 16. Maybe let's make that look better. Now you can at least see both those negative 8x's. So if you add those up, you notice that you do get negative 16. So that's what you do with 3 terms. This is going to give you an alternate method of solving these trinomials. But before we do that, this is how you handle 4 terms. 4 terms, you might be able to take out what's common twice. I think we've actually done this before. So I'm going to group these with these 2 and these 2. So if I look at what's common just in these 2, I'm not going to use the rest. I can do this because you'll see we're going to do it twice. X is common, what we left off with, x plus 5. And I'm going to put a plus here because there's a plus in between there. And I'm going to look at the next 2 and say what's common. Well, it's a d. What's left is an x minus 5. And we can only do this if, with the 4 terms, if you have something common again. And notice I do. This and this is common. So I can actually take that out. Do it again. I know that's a double term, but I can still take it out. And what's left over, if I divide this into this, we have an x. If I divide this into this, I have a d. And then that would be the answer. Notice how it's factored. It's in factored form. It's not factored form here, but because we can do it twice, it's in factored form. Well, we're going to do this for the trinomials. So let's pick, and it's really doesn't need to be done here, but it can be. But let's go back and redo part A, method 2. I'm going to take y squared minus 5y minus 6, and I'm going to factor that. So they talk about this right here. Factor out everything that's common. We did. There's nothing common. In the remaining expression, find 2 numbers that multiply to AC that add up to the B. So we did that. They were negative 6 and 1. But instead of writing this here, that's why we really don't need this for this one. But let's go ahead and try it anyway, just so you can see that it does work. I'm going to write this, and I'm going to break the middle term into 2 terms using the result. So I'm going to use my negative 6 and my plus 1 to rewrite this. Notice I'm making it look like 4 terms. I haven't changed anything because negative 6 plus 1 is negative 5. Then we can do this to it. We can break this up into 2. Say what's common here is a y. What's left over is a y minus 6. Put a plus here. Nothing's common. When nothing's common, I'm just going to put a 1. And what's left over is a y minus 6. So then notice how a y minus 6 is common. And what's left over, if I divide the y minus 6 in the first, I get a y. Divide the y minus 6, put up a plus. And divide a y minus 6 in the second one, I get a 1. And we have the same answer as before. So that's what example 3 is going to show you. Now, for this one, there's really no reason to do that. Those numbers were the answer. But because of this 4 here, and notice how there's nothing common, you cannot, it's harder to do this as a guessing game because it's not going to just be 2 factors of 12 that add to 19 because that 4 is going to mess around. So if we went for the first, it would be kind of tough because, first of all, the first term, we don't know if that's going to be a 4m or a 2m and a 2m. And then what do we have? Maybe 6 and 2. It's not going to be 2 factors of this that add to 19 anymore. It's going to be about the outer and the inner, and those 2's mess it up. So here's like, for instance, a 8 and a 12. That makes 20. It's close, but you can be here all day. So that, I'm going to erase that, because that is why we're going to do this. So what we're going to do is we're going to multiply these two, and we get a times c. A times c is 48. And we look at 2 factors of 14 that add, 48 that add to 19. So let's just look and see if we can come up with those. So we have what? 2 and 24. We just kind of go through our list. Maybe 4. And I missed 3. 3 and if I divide that into 48, I get 16. Ooh, there it is. So what I'm going to do is I'm going to take the 4m squared, leave that alone, make this a plus 3m plus 16m plus 12. And then do this method. 3m. Nope. 3 is not common, just an m. What's left over is an 4m plus 3. Put a plus in between. What's common here is a 4. 4 is the greatest common factor. What you left is 4m plus 3. And then notice it wasn't 2m and 2m at all. It was 4m plus 3 is one of the factors. That's common. And you divide that into each. What you get left is an m plus 4. That is the answer. So you can do that with each of them. Now, this one right here is really backwards from our last section. This one is going to be like part B because this is a perfect square and this is a perfect square. So we might be able to still do this one. And 36 times 25 is an awfully large number. So I'm going to just try it. I'm going to try a 6y and a 6y there and a 5 and a 5 there because I notice that that would be 30 and 30. So that is the a squared plus 2ab plus b squared formula that we did on the page before. The same with this one. This one is the a squared minus b squared, the difference of 2 squares. And if you remember, those were different signs. So if I look at that, this one is probably going to be a 2x. I don't have to go through this for those two. And this is a 3 and a 3, but we just do different signs. And that's going to work because if you check this, that's 4x squared. And then the outer, let's just do our backwards rainbow. 6x and a minus 6x goes away. The first is a 4x squared. The last is a 9. So that does work. So go ahead and try exercise 3. Here are the answers of the last two.